Good morning, my dear friends. My name is Ranveer Kashyap, and today in this video, I am going to talk about motion and time. Now, motion and time is a basic thing which most people know. That motion is the movement of a thing from one particular place to to another particular point. Okay, so the motion is the movement of an object. Okay, now what is time? Time is the now you cannot exactly define time because time is time itself. But time is the measurement of the amount of everyone knows what time is. Okay, everyone knows what time is. Time is the amount which you measure in to get your works done easily. For example, 1 year, 1 day, 1 second, one plank. Okay, now plank is the shortest amount you can go according to science. So what is distance and displacement? Distance is the measure of the path length between two points locations. In simple word, it is the measure of how far one point is from another. It is basically displacement. Okay, it is basically what should I say? It is basically motion. Yeah, it is basically motion. Displacement is the shortest distance traveled between two points. It can also be stated as a change in position of a moving body in a particular direction. For example, let us consider an athlete who is running around a rectangular path. Okay, he starts his race from point A and reaches point D. Okay, as shown in the figure, he starts his no and reaches point C. He starts his he starts his running around a rectangular path from point A to point C. Okay, ignore the point D. Now he goes from point A to point B and then to point C. Okay, but could the athlete take a shorter path? Because in this path he took it was just 3 meter and 5 meter, which is basically 8 meters. He had to cover 8 meters. Even though it is a short amount, we can cover it just by running. But how can he make that distance shorter? So he can just you know he can just go and in a diagonal motion. For example, he can just go from A to C. Wait, he can just go from here in a straight motion to here, from point A to point C. So as you can see, this has become a right angle triangle. Okay, this has become a right angle triangle. So how would you find the distance he covered? How now we all know he covered 8 meters. Say he took 1 minute to cover 1 meter. So he took 8 minutes to cover 8 meter. So if he wants to do so, if he wants to do so in a short amount of time, he would need to do some other thing. Some He would need to like go from one point to other in another manner. So how will we find this place? How do we find the displacement? Now displacement is basically shortcut. Okay, so if someone asks you to find the shortcut from here to here in a short amount of time, it is basically displacement. Okay, So if, and again, if this athlete goes in a circular motion, and the motion, and he goes from here to here, and it is 22 meter for example, and the diameter is 14 meter. Okay, the diameter is 14 meter, and he just went in a semicircular motion here. So he covered 22 meter, and say he covers 2 meters in 1 minute. Okay, he took 11 minutes to complete this. But what is the displacement? The displacement is of 14 meters, because he just moved from point A to point to, wait, he just moved from this point to that, to this point. Okay, so that was again the example. So how do we find the displacement in this, in the triangular path? Okay, so to do this we use the Pythagoras theorem, or we use the formula of Pythagoras theorem. The formula of Pythagoras theorem is h square is equal to, wait, let me write it properly. The Pythagoras theorem is equal to h square is equal to p square plus b square. Okay, so how do we know what is h, what is p, what is b? So if we consider this to be h, so how do we find the h at first? The line opposite to 90 degree is always the hypotenuse, or h. Okay, and the line adjust, and if this one is like this, there are certain formalities that consider the the uh, perpendicular and base, but we can take perpendicular and base as anything as of now, because we don't need to get into that kind of stuff. Okay, so this is perpendicular and this is base for now. Okay, so if we need to solve this, we would write wait, yeah, we would solve it like we would solve it like h square is equal to 5 square plus 3 square. Okay, so 5 square, the square of 5 is 25, and the square of 3 is 9. So 25 plus 9, we would quickly add it up. And the answer is 34. So the answer is 34. The answer is 34. No, the answer would not be 34. The answer should be 34, but it should not be 34, because the 34 is not a perfect square. Now there's a problem. You get how we would solve it. Okay, let's try to do it again. The square of 5 is 25, the square of 3 is 9, and 25 plus 9 is 34. Yes, it is 34. Then why isn't it adding up? 34 isn't the square of anything. You just get the way I'm saying it. Okay, you do get it, right? So that was displacement. We use the hypotenuse formula here, And the next thing we talk about is speed and velocity. Okay, the next thing we talk about is speed and velocity. You may have noticed the motion of a tortoise or a snail. We can say that they move very slowly. Similarly, we consider a bicycle and a car moving in the same direction. We can say the bicycle moves slower than the car. How are we able to decide whether a motion is slow or fast? Okay, how are we able to? In order to help us distinguish between slow and fast motion, we consider a quantity known as speed of the motion. Speed is defined as the distance covered by an object in unit time, or in simpler words, the measure of how fast something is moving. That is, speed is equal to distance upon time. Okay. The SI unit for speed is meter per second. For example, if a car is covering a distance of 100 meter in 2 seconds, then its speed is 50 meters per second. Okay. Now there is a fun fact. The fastest land animal is cheetah, which has recorded the speed between 109.4 km per hour and 120.7 km per hour. But the fastest animal or the fastest being on this earth is currently the peregrine falcon. It is the fastest bird and the fastest member of the animal kingdom with a diving speed of 389 kilometers per hour. Okay, in order to understand speed we need to understand, in order to completely understand about the motion of an object, we should know about the object as well as the direction in which the object is moving. Velocity is the rate of displacement of an object. It can be referred to as speed in a particular direction. It is defined as distance traveled by a body in a unit time in a given direction. That is, velocity is equal to distance displacement upon time. So we are basically getting the formulas for speed and velocity. Speed is speed upon distance. Speed is equal to distance upon time, and velocity is equal to displacement upon time. Velocity of an object can be negative, positive, or zero. The SI unit of velocity is also meter per second. It is always less than or equal to the speed of object. Okay. Now, what is uniform and non-uniform motion? So, if we say like here, let me just go into that markup more once more. Here, if we say, wait, yeah. Here, if we say that uniform motion is, for example, let me give you an example. For example, this is a road, okay, and a bicycle is a wait. Let me draw a bicycle properly. A bicycle, these are the two wheels of the bicycle. This is the, the, what should we say, the ring, the chain of the bicycle. This is the place where the seat connects here. This is the seat. This is the connection here, and this is the handle. Okay, so this is basically a bicycle. So if this bicycle covers this distance in a straight motion without turning anywhere, without going in a curve like this, or even just moving slightly in a curve like this. Okay, if this goes like that without because here it is in a curve because the lane is in a curve. So if the bicycle moves in a motion which does not have a curve like this, the cycle moves from here to here without any curve. It just goes straight. The cycle is then performing rectilinear motion, and that is when uniform motion happens, and uniform motion also has one more circumstance. If the cycle keeps a consistent speed in this standard path, if he goes in a rectilinear motion and keeps a standard speed, the motion will be considered uniform motion. But if the cycle, for example, covered the distance which it covered, the distance which it covered was like this. It went from here to here to here to here, and then stopped there at his house. Okay, the cycle owner's house, not the cycle's house. It went like this. Okay, so this would be considered a non-uniform motion even if the cycle maintained a particular amount of speed. And non-uniform motion will also be when the cycle does not maintain a particular amount of speed in a rectilinear motion as well. Okay, now what is acceleration? In a non-uniform motion, the speed and the velocity varies with time. The rate at which the velocity varies is called the acceleration. In simple words, acceleration is the change in velocity per unit time. The SI unit for acceleration is m s negative 2. If the velocity of an object varies from an initial value u to the final value v in time t, then acceleration a is given by acceleration a is equal to change in velocity v minus u upon time. Okay, now change in velocity is equal to v minus u. Okay, a is positive if the velocity increases with time. A is negative if the velocity decreases with time. Okay. A is 0 if the velocity is constant. That is when the object is in uniform motion. Measurement of time. Time is an interesting physical quantity. You can measure time in almost every point of our daily day-to-day life. We need to measure time to track the progress of our day-to-day activities. Measuring time was puzzling in the early ages. We then found ways to our ancestors then found ways to use as hour clock which contained a certain amount of sand, and then it slowly but surely goes into the other side of the clock through a narrow path. Okay, a very narrow path which allows only a certain amount of sand to go. Now an hourglass or an hour clock has a certain type of shape. So the shape we see here is usually like this, but the thickness that is in the middle, the thickness that is here in the hour clock varies in how much time it goes through. Okay, if we do not want to vary the thickness of this place so that this hour clocks, the balance of the hour clocks, the structure of the hour clock is strong, we would just increase the size of the hour clock and the narrow path also. Okay, it will just increase according to the ratio. Okay, then then our ancestors at before our then when our ancestors got used to our clock and they thought of getting an advanced way to know time during the day, they used sundials. Now how did sundials even work? So for example, let me just open it. Yeah, so for example, the sun is right here. Okay, no, the sun is not here, but the sun is actually here. Okay, it is emitting the light, the sun rays, and then the shadow emitted from this the shadow emitted from this goes into a particular motion. Okay, so it just you know it just moves, the shadow of it moves with the sun. So that was all for today's video. Bye and have a nice day, and please like and subscribe to my channel, and share the video if you liked it.